This is journal page 394 for lesson 16.7. And to start, we're finding the sum of number 1 and 2. We have to write our answer in scientific notation. Number 1, 2 times 10 to the 4th plus 7.2 times 10 to the 4th. Well, they're to the same power here of 10, so we just add the factor 7.2 plus 2, lining up the decimals, of course, and we get 9.2. So our answer is 9.2, and we keep the same power of 10 times 10 to the 4th. And that is in scientific notation. Number 2. We have 3.2 times 10 to the negative 2 plus 9.4 times 10 to the negative 2. So good times, our 10s are to the same power again. So we just add these up, 3.2, 9.4, we get 12.6. 12.6 times 10 to the negative 2. However, this is not in scientific notation. I do need to move this decimal one spot by 1 power of 10 to make this smaller. So we need to make this 1 power of 10 larger. So this will be 1.26 times 10 to the negative first power. Number 3. Now for 3 and 4, we're finding the difference. 6.7 times 10 to the 5th minus 4.3 times 10 to the 5th. Wow, good times. These all have the same power. That's a little too easy, but whatever. We'll take what we can get. So I have 6.7 minus 4.3. And I get 4 and a decimal and a 2. 2.4 times 10 to the 5th. And that is in scientific notation. Number 4. 8.9 times 10 to the negative 3rd power minus 1.9 times 10 to the negative 3rd power. Same powers of 10, so I just subtract 8.9 minus 1.9, and we get 7.0. So we just have 7 times 10 to the negative 3rd power. Wow, those were all almost too easy. I wish they could have challenged you a little bit. Remember that if they did not have the same power of 10, which all of those did, but if they did not, you would have to change one of the numbers so that they did have the same power of 10. You can remember to watch the lesson that went along with this, going through the examples. Well, for number 5, we are finding the product. So we have 6 times 10 to the 8th power times 4 times 10 to the 6th power. And we multiply the two factors to get 24. And remember, when we multiply bases, the same base, we add the powers. So times 10 to the 14th. Not in scientific notation yet. We do move it one spot over here to make it smaller by 1 power of 10. So we make this larger by 1 power of 10. And we get 2.4 times 10 to the 15th. Number 6. 9 times 10 to the negative 3rd power times 9 times 10 to the negative 3rd power. 9 times 9 is 81. Times 10 to the negative 3 plus negative 3 is negative 6. This will go to 8.1, and this will be negative 5. So 8.1 times 10 to the negative 5th power. Number 7. Eight times 10 to the third power. And I know it shows it with a little division sign, and then it's going horizontally. I'm going to show it vertically like this. 2 times 10 to the second power. 8 divided by 2 gives us 4. And 10 to the third power over 10 to the second power leaves us with 10 to the first power, or just times 10. I'll put it to the first power like that, because it is supposed to be in scientific notation, and we need our 10 to some power. 4 times 10 to the first. For the second one, I'll leave it how they have it horizontally here. 2.34 times 10 to the fifth divided by 7.8 times 10 to the fifth. Well, 2.34 divided by 7.8. I have no idea. So 2.34, 7.8. Move it once. So 78 into 23.4. Decimal goes straight up. I'm going to go with a 3. That is fantastic, 0.3. And then I have 10 to the fifth and a 10 to the fifth, which we're dividing. So 10 to the fifth divided by 10 to the fifth will be, remember we subtract those, times 10 to the 0 power. Now we're not going to leave it like that because we do need to move this decimal one spot. Although, if this decimal had been here, we would leave it like that to be in scientific notation. But we do need to move that decimal one spot to make this number bigger. So we need to make this 1 power of 10 smaller. 3 times 10 to the negative first power. And then finally, how many times greater is the radius of the basketball than the radius of the marble? Well, if we want to know how many times greater it is, we divide. So for number 9, we will take 1.143 times 10 to the first power divided by 5 times 10 to the negative first power. 1.143 divided by 5. So 2, 10, 14, it goes in twice again, which is 10 again, 43, goes in there 8 times, which is 40, and 6 times, which is 30. All right, so we have 0.2286, 10 to the first, over 10 to the negative first would be times 10 squared. We do have to move the decimal one place here, making it larger, so we make this one smaller, making our answer 2.286 times 10 to the first power. And then they did not leave it in scientific notation. They just want to know about how many times greater. So if we multiply this by 10 to the first power, which is just 10, it becomes 22.86, which is about 23 times greater. I included the little about symbol in my answer, so we know that it is just an approximation. Excellent!